warahmatullahi wabarakatuh. Good morning, everyone. So,
Waalaikumsalam.
this morning we will learn about hypergeometrics. The PowerPoint is clear. Slideshow in the slideshow.
Yeah, it's clear.
Everything?
Yes,
Okay. Okay. So in this morning we will learn about the other discrete probability distribution. Now we move to hypergeometric. So this is a concern about hypergeometrics. The basic hypergeometric, and then multivariate hypergeometrics and negative hypergeometric. So if we we take a look about the key point, hypergeometrics is the probability that we take someone without replacement. Wait a moment. Maybe I will. Oh, I'm sorry. Okay. So hypergeometrics, we are concerned about something sampling, or we taken some item atau some sample without replacement, without replacement. So this one, okay. So without replacement is about hypergeometrics. The basic hypergeometrics is the original one. So we can mix this. This is for like a binomial distribution. So in hypergeometrics, we take without replacement. If we take a look at the multivariate, so this outcome is uh, more than 2. So we call it multivariate hypergeometrics. So we concern about the outcome more than 2 with without replacement. So this is the multivariate hypergeometrics. And the next one is negative hypergeometrics. Negative hypergeometrics, the same. We take a sample without replacement, but we calculate about the experience until we have S success, the N success. So this is about the hypergeometric, multivariate hypergeometric, negative hypergeometrics. So if we wait, I will. So if we have a summary about a distribution, a discrete distribution, we have a lot of distribution. The first one we know about Bernoulli. This is have two outcome like success and failure. This one only one experiment. So this is a Bernoulli. And then the second one is we know about the uniform discrete distribution. This is we have the same probability for all random variable. I'm sorry. Wait. Random variable. The third one is, can you see my screen? My screen is have some trouble. Any trouble? Wait. Okay. So in distribution, discrete distribution, okay, we have some. The first one is we know about Bernoulli. Bernoulli have two outcome. One, experiment, fail, and success. And then we know about uniform, discrete distribution for the uniform. They have the same probability for each random variable. And then the next one is about Poisson. Is we have the interval. The example is time. The next one, we know about the binomial distribution. They have two outcomes, like the Bernoulli, but they have an experiment. And then the next one is, the next one is we learn about multinomial. They have more than two outcomes, like minor, medium, near effect. And then we learn. And anyone still remember the other one? Geometrics. The first success. Okay, this one. So now we move on to the hypergeometry. So the hypergeometric distribution, they represent the distribution of random variable that denotes the number of successness in the end trial without replacement. So we have some key point. without replacement. This is maybe the same with the binomial distribution, but in binomial distribution, this is with replacement. But in hypergeometric distribution, we without replacement. They have n trial and experiment without replacement. So the random variable range from zero success to the successful. Okay, the next one. The random variable x represents the number of selected success from the sample point. Since success and failure are mutually exclusive, so we can calculate with this formula. This is the combination of n object taken at n at a time. So this is, we call it sample point. This is the random variable. This one is the number of all of the number of this one say selected from n min d, and this the population. Okay, and this is a sample point. This is about number of failure, and min x, this is the number of failure. This is the success. This is number of failure. This is the sample point. This is the population minus with the sample point. This is the observation and object taken n. So this is n object taken n. So we calculated with the combination of this formula. This is for the hypergeometric distribution. And then we calculate about this formulation with the previous formula. We can, yes, this is about the detail about how the this formula can be taken for the hypergeometric distribution. So this is permutation of distinct object, probability of selection without replacement. Because the probability without replacement, they have different calculation. We must subtract the number of the sample size of the number of the population. So we have a simple we have the simple formula for the hypergeometric distribution. So the application of the hypergeometric distribution include the number of successful events from unlimited sources with a portion classified as successful, the number of defective product, the number of women chosen as daily cooperative board member from the cooperative member. So this is the parameter for the hypergeometrics: number of finite population, number of population success, and number of trial. And with a small capital, this is n. D capital, the number of population success. This is lowercase. With n with lowercase, this is the number of trial. D, number of population success. So this is the formula for the probability mass function. We will take a look about the probability of the condition. So this is the hypergeometric. We denote with the its geom parameter n. N is the number of finite population. D is about the sample size. Number of number of population success, and n is number of trial. This is how to calculate the mean and variance. So we move to the example. So the experiment of drawing 3 marble. So we take 3 marble and from a total of 25 marble, there are 22 red and 3 yellow at once by one or by one without replacement. So if we have this key point, this keyword, so we must calculate it with the hypergeometric. If in the question we have this one without replacement, so we must calculate it with the hypergeometric. Where throwing or yellow marble is considered as a success and red marble is a failure, so what is the probability of getting 0 success? What is the probability of getting at most 1 success? And what is the probability of getting more than 1 success? So we can calculate, this is the equation, x equal to 0, p x less than equal to 1, p x more than 1. So this is, we use the formula for the probability of the 0 success or no success. 3 is the drawing without replacement. So total number of marble. We take 3 from 25 marble. Number of yellow marble is 3. This is, we call it a success. So D is 3. So from this formula, D x, so this is combination of 3, 0, 22, 3, 25, 3 divide by, so we can calculate about the probability of 0 success. And then the probability of less than 1 success, we replace this one with the 1. So the probability less than 1 success, it means that less than 1. So this probability 0 and probability 1. So we calculate the probability of 1 success. This is 1 success. This is 0 success. 0 success is the same like the above. This is the same. This is probability of 1 success. I'm sorry, 0 success. This is probability to have 1 success. So this is the probability of less than 1 success. We must calculate the two probability, because less than we have 0 and we have 1. And then the probability more than 1 success. So if we calculate probability 2, probability 3, it's okay. We have some calculation this one, or we can have the other alternative to calculate it with 1 subtract with a probability of less than equal to 1. So this is the same with this one. So we can calculate it. 1 minus with the previous one, we has been calculated this one. So we can calculate with this one, or we just calculate for the probability 2 plus probability 3. So the next one is estimated mean. We can calculate with this formula, and we have the estimated mean. About the estimated variance, we have this formula. This formula we can taken from this is the summary about how to calculate mean and variance of hypergeometric distribution. Okay. The other example is about the risk of the product defect. So the craftsman produce 20 woven roof toy. So this is about N. Among them, 5 is have a defect. So we consider defect as a success. But the defects are not noticeable unless examined closely. A child buy 3 of this product. So they buy 3 this product. In lowercase and with lowercase, what is the probability of that the child get no defective product? What is the probability of get at most one defective product? And what the probability of get more than one defective product? So we from this question we can have some number input number that we can calculate it later. So n with capital letter is 20. Defective product we consider it as a success. This is 5. Number of purchase is 3. So we have this one 5 because this is D 5, then 0 0 because this is x, D x, and then n with capital letter, and we taken I'm sorry, this is n mean D, this is I'm sorry, n mean ds, this is we taken it, and with the lower capital. So we take a look at this formula. This one. So we can calculate this one, the probability of no defective product. For the probability of less than equal to 1 product, so we calculate the probability of 0 and the probability of 1. This is the same. We calculate it. So this is the difference. This is because 1 defect. This is 2. Become 2. Because in this formula, we n with lowercase minus with x. We follow this formula. So we have this probability, and then more than 1. More than 1, we have P2 plus P3, or 1 mean P less than equal 1. Like the previous example, the estimated mean and the estimated variance. The next one is the other example. In celebration of the country Independence Day, a store offer customer who spend at least 100,000 rupiahs the chance to draw a lottery. They are 10 grand prize, a 90 prize. So we have a 10 grand prize and 90 consolation prize. So the coupon are folded and packed in the lucky dip. The first customer get the opportunity to draw 3 coupon. So about the coupon, we this is have a lottery. So we can make some summary about the case study. So this is the total number of coupon is and 100 number of grand prize. This call it as a success, and then the drawn couple number of coupon drawn. This is 3. So we can calculate getting 0 grand prize, less than equal more than. We have the same formula, but we take another numeric. So the formula is the same, but we can apply with the case study. This is a central committee selection. So in organization, a meeting is held for form a new central committee. The central committee consists of 10 members selected from candidate nominated for each branch. Each branch nominates its 5 candidates. The organization has 20 branches. So this is for the sample. This is we taken from 5 candidates, nominate 5 candidates, withdraw 5 candidates from 100. So what is the probability? Not represent in a branch is not represent in the selected central committee. What is the probability branch represented by most 2 selected candidates? We have this is 2 less than equal to, and then this is probability a branch are selected in central committee is equal to 5 and etc. So we have a summarize for the case study like that, and 100 from 20 brands multiply with 5 candidates. The committee member is 10. We taken it in a 10. So the central committee consists of 10 members of 20 branch nominate 5 candidates. So we have 100 candidates. Nominated per branch is 5. We calculated it as a success, and the number of selected committee member is 10. So we calculated the same formula with the different number. So this is about D, success, number of success. This is N with capital letter. We subtract with N with lowercase. So we calculated like this one. Probability of branch is represented by less than 2 candidates. So less than 2 candidates, we have 0, 1, and 2. Like this, we calculated with the combination. The next one, probability of that all 5 candidates from branch are selected. So this one, we have this one and calculated. Probability that branch is represented by more than 2. More than 2, so we can calculate this one. 3, 2, 5, calculate. We have the same answer. If we use this with this one. So this is the same. Okay, estimated mean and estimated. So we said that we can estimate about the parameter. So we take a look from population, and with 100,000 or 100 trial sample are taken with 5 rounds without replacement in each trial. So we have this frequency. This is frequency relative. Frequency relative is if we calculate it, this is the sum is 100, and then this one we divide it with the sum of this. So we have frequency relative, and then we calculate x multiply with the frequency relative. So this one we multiply with frequency relative. 0 multiplied by 1.33 is we have 0. Like this. This one, 2, this one. We have, this is the frequency relative. And so we calculate about the mean. The mean is 1.05. And then this is we calculate x minus with x bar, x bar is means, so this one we minus with this one and we square it. Okay. This one we have, this is the about the variance. So we can calculate about the estimated mean. This one. So we have D in this one. The variance we have obtained value D1 and D2. So the estimated mean is one. Okay. This is the hypergeometric distribution. So this is the key point. The keyword is without replacement. Now we move to multivariate hypergeometric distribution. The multivariate hypergeometric distribution, if we have the outcome is more than 2. So this one, 1, 2, 3, 4, and etc. So this is the combination of n object taken from n. This is the same, but we have the other outcome. We take a look at the drawable, the example. So the drawable example, the same like previous, but this is have many color. So what is the probability of drawing marble consists of 5 red marble, 1 green marble, 3 yellow marble, and 1 blue marble. This is the same with the multivariate, but in this case is without replacement. So we call it multivariate, multivariate hypergeometric distribution. So the formula is just the same with the hypergeometrics, but we multiply with the other outcome. So take a look at this one. Sorry. So the probability of drawing 10 marble without replacement and obtaining exactly 5 red, 1 green, 3 yellow, 1 blue is like this one. So we calculate it like this. This is the first one is, I'm sorry. A1, X1, D2, X2, D3, X3. So this one, why 14? Because this is have 14 red. They won 5, so 14, 5, and then 6, 1, and then 3, 3, and then 2, 1. It is relatively easy for the multivariate. This is, we take 10 marble from total 25 marble. So we have the communication of this one, we multiply it, and we have the probability. So this is the probability of multivariate hypergeometrics. The other example is about the cake distribution. On this business produce 100 pieces of cake daily that are distributed to 4 cake stall A, B, C, D. So 15 cakes to A, 20 cakes to B, 30 cakes to G, and 35 cakes to D. What is the probability that number of cakes sold is 15 at A, 10 in B, 8 at B, and etc. So we can calculate it like this. So this is very simple. 15, the sold one is 15, then 20, 10, and then 30, 20, and then 35, 15. This is the total about the keep and sold one the taken. So we can calculate this one. This is marketing agent, the same by agent. Transportation company have 5 agent A, B, C, D, E to sell ticket for its fleet. Each vehicle have 20 seats available. So find the probability that the number ticket sold is 10 by A, 5 by B, etc. So we can calculate it relatively easy. 10 by A, 20 seat probably 20, 20 the seat, this is the seat, have the same seat for uh, agent A, B, C, D, E have the same, but this is A, calculate with the combination. This is the total ticket. This is the total ticket, and then we draw it. We solve it in 20. This is for the multivariate. And then the negative hypergeometric distribution. The same with the hypergeometric, the other hypergeometrics. This is without replacement. But because this is the negative hypergeometrics, this is conducted until S success obtained. This is relatively same with the negative binomial distribution, but in this one, they without replacement. This is the application. So the number of drawing required to obtain a certain number of success from unlimited source where some item as considered success. This is the number of quality control sample extraction from unlimited stock until a certain number of defective products are found. So this is the formula. This is only have 2 outcomes. This is maybe for success. This is for failure. This is the formula. This is the summary. Numbers the same. Number of success. So we can calculate like this one. The example. In a group, there are 6 men and 4 women. The group must complete 10 tasks. It assigned to one representative. The next task is assigned only after the previous one is complete. Each member is allowed to complete only one task. What is the probability of the 5th task and the third woman is assigned to the completed? This is what the probability that all 4 women complete the first 4 tasks. This is success occur if the assigned member meets the specific gender. Total group is 10. Number of member by gender is the man is 6, the woman is 4. The probability that the third woman is assigned to the 5 tasks is 1, x5 s3. So we calculated with the formula and we have the probability. For 4 women, so this is the 4th woman. This is N4 S4. We calculated with this formula. This one. So we can just only apply the formula. The challenging is we define which probability. So in the previous semester, many students they can differentiate between one distribution, one type of distribution with the other distribution. So it makes they have a bad score. So the first one is you must know about the characteristic of each of discrete distribution probability. So for the formula, we can look at the node or the slide and we just apply it. But I think you must practice to calculate, so you have uh, maybe you have easy to calculate and in a short period of time. So this is the mathematical function in spreadsheet application for the multinomial, and then this is for hypergeometry. This one in Excel, it is hypergeometry. So this is the end of the uh, the discussion about hypergeometric. Maybe any question? Yes. Yes. I think you must prepare it if the mid exam is open, so you must prepare it. You can just download from the browsing in the internet, and you can. I'm sorry. It's okay. You can download from online, or if you have a book about statistics book. In the end of I think in the maybe in the end of the page, they must have uh, they will provide about the distribution, all kind of distribution, but with discrete distribution or continuous distribution. So if maybe if you don't have maybe if you have a limited time, you can borrow from the library in sixth floor. There are many book for the statistic, and in the end of the book, they provide the uh, distribution, the table for the distribution. So if you don't want maybe download from the internet, you can just take from uh, book in the library. Okay, pleasure. Okay, if there is no any other question, we will meet tomorrow again. We discuss about some our previous practice. So maybe tomorrow I maybe give some the other exercise or only to decide which distribution. This is what distribution. So for I think for you, it is easy to calculate if we have known about the formula, and the challenges is what type of the distribution probability. So thank you very much for your attendance. See you tomorrow. Bye bye. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you.